I will now start building bush 2. Let's look at the slide to see the sketch and how the body output looks like. For this step, we shall use the commands offset, circle, pad, add, edge fillet and insert in a new body. Let's take a look at the drawing again to identify the dimensions. We can see that the outer diameter of the bush 2 is 82 mm from the top view and the inner diameter is 40 mm as seen from the section view. Back in the CATIA window, I will first go to Insert from the Tools menu bar and click on the geometrical set. I will name this as bush 2. I shall also insert a new body and rename it to bush 2 by using the Alt-Enter key. Now I will press Ctrl+C to copy sketch 2 under bush 1 geometrical set and then press Ctrl+V to paste this sketch under bush 2 geometrical set. This allows me to copy the sketch from bush 1 to bush 2 geometrical sets. Now I will double click on sketch 4 under bush 2 geometrical set to make this sketch editable. From the top view of the drawing, we can see that the center of bush 2 is at 60 mm from the right end of the base. So, I will modify the distance of the vertical axis from the right end of the base to 60 mm. You may even draw another new axis and mark the 60 mm distance if you want. Next, I will delete the existing circles and the 15 mm distance constraint as shown. To do this, I can simply press and hold the Ctrl key on the keyboard and click on the circles and 15 mm dimension and hit the delete key. Now you can see that the horizontal axis is free to move in the vertical direction. I can constrain it to the yellow horizontal axis by using the coincidence constraint. I now have the center for the bush 2 sketch ready. Next, I will select the circle command from the profile toolbar and draw two circles of diameters 82 mm and 40 mm each. If the circles are seen as construction circles, you can multi-select the circles by pressing and holding the Ctrl key and then clicking the Construction or Standard Element command on the Sketch Tools toolbar. Now the sketch is fully defined, so I will exit the sketcher. Moving further, I will right-click on the bush 2 body, the one with the gear icon, and select the Define in Work Object option. This allows us to place the following actions in the body. Observe that bush 2 part body is underlined. Now I will click on the Pad command and select the most recent sketch for profile or surface selection in the Pad definition window. Since the sketch was made on the plane 1, the length of the pad is 26 mm. I can click on Preview to make sure that the direction in which the pad is applied is correct. And then click on OK. If the pad direction seems wrong, we can use the Reverse Direction button and correct the same. Let's use the graphics properties to change colors of each body in the specification tree. To do this, I will select the bush 1 part body from the specification tree and click on the first drop-down list of graphics properties toolbar. Now I can select any color to change the appearance of bush 1. Next, I will select the bush 2 part body from the specification tree and apply a different color to this body. If I try to select a body from the graphics area, I can only select an edge or a face of the body with one click. I will have to multi-select all the faces to apply one color to the whole body. So it is easier to select a body from the specification tree. Next, we shall use a new Boolean operation called add to combine both bush 1 and bush 2. This operation combines the two bodies into one. I will right-click on the bush 2 part body, then click on bush 2 object, and then click on Add. In the Add definition window, we can see that bush 2 is populated in the Add field. For the 2 field, I will select bush 1 part body from the specification tree. If you click on Preview in the Add definition window, you can see how bush 1 and bush 2 are combined in the graphics area. Now I can click on OK to exit this command. If I right-click on the Pad 2 under bush 1 part body, then click on Pad 2 object at the bottom of the menu, I can select Insert in New Body option. This adds a new feature called Assemble 1 under the bush 1 part body. To complete this step, I shall click on the Edge Fillet command from the Dress Up Features toolbar and select the joints where bush 1 is connecting with bush 2. I shall apply a fillet radius of 10 mm as shown in the top view of the drawing. You can rotate the model to make the selections in the graphics area and also zoom in or out to have proper access to the edges. This marks the end of this step. Let's take a look at the slide to see what the next step is. To create these corner bushes, we shall use commands like axis, offset, circle, pad, and edge fillet. If we look at the top view of the drawing, we can understand that the outer diameter of the corner bush is 26 mm. The center of the corner bush on the top right side is at a horizontal distance of 43 mm from the right end of the base. The horizontal distance between the centers of two corner bushes is 114 mm. Height of the corner bushes is 35 mm from the bottom of the base. Let's jump into the software and insert a new geometrical set and a body and name them corner bushes. You know how to do this by now, right? Next, I will right-click on Sketch 2 from under Bush 1 geometrical set and click the Copy option. I will now right-click on the corner bushes geometrical set and click on the Paste option. Then, I will double-click on the new sketch to edit it. I will hide the bodies by selecting them in the graphics area and pressing the spacebar on the keyboard to have a better view of the sketch. Next, I will delete the circles by multi-selecting them and hitting the Delete button on the keyboard. Let us also delete the horizontal axis as it is not required for this sketch. Next, I will edit the distance between the vertical axis and the axis at the right end of the base sketch to 43 mm. Next, I will draw two circles of diameters 26 mm and 12 mm each. I will multi-select these two circles and then select the mirror command from the operation toolbar and then select the yellow vertical axis. This step creates a copy of these two circles on the other side of the origin. Next, I will repeat the mirror operation by multi-selecting all four circles you see in the sketch. You can see that the sketch is iso-constrained. I will now exit the sketcher. I will now click on the Swap Visible Space command to see the hidden objects. If I hide the bodies from there, I will be able to see them in the normal visible space. I can click on Swap Visible Space one more time to go back to the graphics area. Let's recall that the corner bushes sketch was done on plane 1 as it was copied from a previous sketch. I will right-click on the corner bushes sketch, then click on the sketch object and then click on Change Sketch Support. Now in the sketch positioning definition window, let's change the reference plane from plane 1 to XY plane. I can select this XY plane from the graphics area or from the specification tree. Now I will click on OK to exit this window. Let us now define the corner bushes body as the work object and then select the pad command from the sketch-based features toolbar. From the section view of the drawing, we can see that the distance from the top of the base to the bottom of the base is 30 mm. Total height of the corner bushes is 35 mm as seen in the other section view. So in the pad definition window, I shall give 30 mm as first limit and 5 mm as second limit in the length fields. Let's see the preview. Click on the reverse direction button if necessary and then I will click on OK to exit this command window. Next, I will use the Edge Fillet command from the Dress Up Features toolbar to convert sharp corners into smooth edges by applying a fillet radius of 2 mm. I have selected the outer edge of the corner bush and applied 2 mm fillet radius. Now, I shall apply the same 2 mm radius fillet to the top face of the corner bush. Do you see the difference? The fillet can be applied to edges and faces as needed. I shall apply this fillet on the outer edge of the top face of all the corner bushes. Let us apply a new color to the corner bushes from the Graphics Properties toolbar. The corner bushes design is now complete. Let us now learn another new command called Change Part Body. This command makes the selected part body as the main part body, under which we can place other part bodies using the Boolean operations. Let me demonstrate this feature now. I will first insert a new body from the Insert menu bar. I will rename this body as Bush Holder. Now if I right-click on the Bush Holder part body and click on the Bush Holder object, I can see an option called Change Part Body. If I click on the Change Part Body option, Bush Holder becomes the main part body and will be reordered to the first position in the specification tree. Next, I will right-click on the base part body and then click on Base Object at the bottom and then select the Add command. In the Add Definition window, I can see that Add field is filled with base. To field is filled with Bush Holder. Once I click on OK, the base will be added under the Bush Holder part body. The Bush Holder design seems to be complete with all the features. But if you rotate the body, you can see that the base is overlapping with all other bodies. To fix this, we shall use another new Boolean operation called Union Trim. Let's see how. I will right-click on the Bush 1 part body, then click on Bush 1 object, and then select Union Trim command. We can see that Bush 1 is populated in the Trim field, and Bush Holder is populated in the Width field. For the Faces to Remove field, I will select the surfaces inside the Bush 1 and Bush 2 in the graphics area as shown. I will click on the Preview button to see if the desired output is seen, and then click on the OK button. Let's do another Union Trim operation. I will right-click on the Corner Bushes part body and then click on Corner Bushes object and then click Union Trim command. In the Trim Definition window, Trim field is already populated with corner bushes. In the Width field, Bush Holder is selected. For the Faces to Remove selection, I select the surface inside the corner bushes that belongs to the base as shown. We can click on the Preview button to see how the trim occurred. I'm satisfied, so I will click on OK to exit this command. If you look at the specification tree, you can see that Bush Holder is now the main part body, and all its part bodies are located under this body, which means that all the features are now merged into one body. Now if you expand each branch of the specification tree, any designer can understand the sequence of steps done for this design. Any further steps will be saved under the Bush Holder part body. If we look at the drawing again, we can see that there are two chamfers, one is on the Bush 2 and the other on the corner bushes. To add these chamfers, first I click on the chamfer command from the Dress Up Features toolbar. Now I will select the inside edge of the Bush 2 on the top. In the chamfer definition window, there are different modes. In this scenario, length 1 or angle mode is applicable. I will update the length to 1.5 and angle to 45 degree. I will click on OK to exit this window. As you can see, a chamfer is created on top of the Bush 2. Now I will repeat the chamfer feature on the corner bushes as well. Let's click on the chamfer command from the Dress Up Features toolbar and select the length 1 or angle for mode field. For the length 1 field, I will type in 1.5 mm, and for the angle field, I will type 45 degree. Next, we need to multi-select the inner edges of the corner bushes on the top for the Objects to Chamfer field. Now, I can click on the OK button to exit this window. Notice how the chamfer commands are placed in the specification tree based on the order in which they were performed. If needed, we can move this command to their respective part body in the specification tree. Let's take a look at the drawing to see if any of the features are pending. The holes on the Bush 2 are still pending, so let's get into it. I will select the hole command from the sketch-based features toolbar and then click on the top face of the Bush 2 as shown. Let's observe the hole definition window. Like the pad and pocket commands, there are types of limits for the hole command as well. That is, blind, up to next, up to last, and so on. In the extension tab, let's leave the blind limit type on. For the diameter field, let's type in 12 mm. As it is an M12 hole, M12 is a standard metric thread. You may refer to your metrics topic to know more about the hole standards. For the depth field, I will type in 15 mm as seen in this drawing section view. I have selected the plane on which the hole should start, but the exact coordinate position is not yet defined. To do this, I can click on the Positioning Sketch button on the right as shown. CATIA places the plane in normal view by default. Isn't that convenient? Now, the Sketcher workbench is active and we have access to sketch tools. I will draw an axis with a coincident constraint as shown. The horizontal distance from this axis to the center of the hole is 60 mm. So, I will add that dimension. Next, I will draw a construction circle as shown and constrain its center to be vertical to the center of the hole. Let's constrain the circle diameter to 61 mm. Now, I will apply another coincidence constraint between the center of the hole and the circle. The sketch is not yet fully constrained. I will use the Project 3D Elements command to project the outline of the base as shown. Now, I will constrain the distance between the newly projected line and the center of the D61 circle to 60 mm. Now the sketch is constrained. If I click on the Exit Sketcher button, CATIA will bring me back to the hole definition window. Making sure the hole direction is correct, I will click on the Type tab in this window. From the Hole Type drop-down list, I will select Counterbore. It is a flat-bottomed hole that extends into another coaxial hole, which in turn can be flat or inclined at the bottom. As you can see in the pictorial representation, these are the different shapes of holes. In the drawing, you can see that the hole shape is counterbore, as per our selection. For the diameter field, I will type in 12 mm, and for the depth field, I will type in 15 mm. The preview seems correct, so I will click on the OK button to exit this window. The hole command is now complete. Now, I will make instances of this hole using the Circular Pattern command from the Transformation Features toolbar. I can click on the Circular Pattern command from the drop-down list under Patterns to open the definition window. I will update the instances to 6 and angular spacing to 60 degree. I will click in the Reference Element field and select the inner face of the bush 2. For the Object to Pattern field, I will select the hole 1 from the specification tree. Preview seems correct, so I will click on OK to complete this command. To avoid sharp edges, I will use the Edge Fillet command on the bushes on the top and bottom. I will apply a fillet radius of 2 mm and 3 mm respectively as shown. I will now insert a new geometrical set from the Insert menu bar and rename it as Constructions. I will drag and drop all the geometrical sets in the model into the Constructions geometrical set. I can do this by left-clicking on the base geometrical set and drag the same on top of the Constructions geometrical set. I will repeat the same for all the sets. Now you can see that all the geometrical sets are grouped under one set. If I right-click on the Constructions geometrical set, I can click on Constructions object at the bottom. Now I shall select the Reorder Children option. In the Reorder definition window, we can use the green-colored up and down arrows to reorder the arrangement of the geometrical sets as you wish. I will move the base to the top like so. Then I will place the bush 1 followed by bush 2 and corner bushes. I can exit this window by clicking on the OK button. When you work on a design, there will be instances where you might need to update a specific area of your design with some changes in shape, dimensions, etc. Defining all the features and grouping them into different part bodies will help you identify and make modifications easily. This slide shows the Boolean operations and cosmetic feature that we used in the last few steps. We saw how union trim is used, how chamfer and fillets are applied. We also saw how we can define industry standard holes and then apply patterns to repeat the same instances using circular pattern. Change part body and reorder children commands help us with organizing the specification tree. The part modeling is now complete. We shall now proceed to the next part of this session,